Everybody, tonight we're looking for the location of some complex numbers, and this admits a very nice geometric interpretation. This very first statement, folks, and let's call this the imaginary axis right here. Vertical axis, instead of calling it the y-axis, let's call it the imaginary axis. We'll call this the real axis right here. Okay, now this very first condition here is the collection of all complex numbers that are exactly 5 away from the origin, okay? So let's just count up here, maybe we'll call that 5 right up there, just, okay, so that'll be the point 0, 5i. Okay, and then similarly, you know, we'll just go all the way around here. We'll call this the point 50 right here. Okay, 50 is this point. Let me just go ahead and try to half-ass draw the circle here. Okay, there we go, part of the circle. All right, and then I'll just go down. We'll call this 5 down here. Okay, we'll call this minus 5 over here. Okay, and so there you are, folks. It's a circle, radius 5, all complex numbers on this circle are what we're interested in. That's half of what we're interested in, okay? Again, let me just label just a little bit more right here. This would be the point 50 right here, 5, 0. And this would be 0 minus 5i. I won't label it. And this would be minus 50 right here, okay? Now, so what's this next part mean? It means not only do you have to be a member of this set called a circle, as far as complex numbers go, you have to be 4 away from the point 70, okay? So I'll label this point right here as 7, 0, right? You know, just to be clear what we're looking for, let me make a big prominent dot right there. Okay, we're looking for points on this circle that are 4 away. That is, let me draw down here. I have, let's say maybe around in here somewhere. Okay, and again, it has to be on this side since the distance is only 4, right? It can't be on the other side of the circle, I don't think, right? So just on a common sense level, this from here to here is 2.5, right? So, excuse me, from here to here is 5. So your points of interest, there would be symmetry going on. They would have to be points somewhere in these regions right here, up in the first quadrant, somewhere down here. And we're talking about the distance to 7. I won't draw any more lines, folks, but from here to here, right? That's a distance of 4. And from here to here, we'll call that a distance. That's what we're looking for, the precise values. And again, it's not much of a leap of faith to conjecture that they will be in the first and fourth quadrants. Okay? Now let's keep on moving. All right, now this is fairly straightforward. This is just a definition of the modulus, right? This is just the hypotenuse of a triangle of length A and B. You know, we have a complex number in the generic form. A is the real part, B is the imaginary part, okay? And since 7 is a real number, we subtract it from the real part. So you have 2 different modulus statements here, okay? And the rest of this is fairly straightforward. I did most of the work for you. Squaring, we square both sides so we can find out what A and B are, all right? Now, you can eliminate however you want. I chose to subtract the first equation from the second equation because notice the A squared and B squared terms go away. All right, and then here, all the arithmetic is done here for you, and so you get A is equal to 29 over 7. Again, I won't spend much time here. All right, and then the arithmetic here was a little nasty. This would tell you B squared is equal to this, right? So this would tell you that B has to equal to, notice you have two solutions consistent with the geometric interpretation. You would have B is equal to plus or minus the square root of 384 over 49. Okay, and remember, b is the imaginary part. We don't have to mess around with I right now, right? It's just the imaginary part. That's how it was defined. Now, folks, this is, again, saving us a little bit of work. 49 is a perfect square. The square root of 49 is 7, right? This ends up being plus or minus 8 root 6 over 7. The reason why is 6 times 64 is 384. You can take the square root of 64 and get 8. You can't take the square root of 6, so you just leave it so-called exact form. And so we get plus or minus 8 square root of 6 over 7. Okay? So that's effectively, that's the answer to the question. But let's just make sure that makes a little bit of sense. Notice that this number is a little bit more than 4, namely it's equal to 4 1/7. 29 divided by 7 is 4 1/7, so this is just a hair above 4. Now this number is a little harder to discern. The square root of 6 somewhere between 2 and 3, right? So you have 8 times the number between 2 and 3 divided by 7, which ends up being between 2 and 3 also. Closer to 3 probably. Now let's take a look at the scaled graph of this, folks. If you take a look here, let me extend this out. This is some computer software that did this for us right here. Let me get this thing always dies on me. Okay, whoops. Okay, notice that this is the right-hand side of the circle. All right, and this point right here would be, let's get the scaling going. You see, we have 5 right here, and so this would extend out to, we'll call this 6 right here, if you want to. And we'll call this 7, right? So you see the points we found, we're talking about the distances. Let me make that, again, as prominent as I can without butchering it, okay? That's the 0.70, right? And so this distance right here, okay, it's hard to tell from, that's horrible, isn't it, folks? Doing my best to make a dotted line. That would be 4 right there. And this distance from here to here is also 4, all right? And notice 4 1/7 looks about right for the x-coordinate, right? Right here, the x-coordinate would be 4 1/7. It looks like it's to the right of 4, right? And now this, 4 1/7. Okay, so this would be 4 1/7. And then you would have minus, what was our number again? Minus 8 root 6 over 7. Okay, minus 8 root 6. And similarly, I won't do the top one, but you get the point. Okay, and again, you can do the math on this, but square root of 6 is between 2 and 3, right? Since the square root of 4 is 2 and the square root of 9 is 3. So the square root of 6 is between 2 and 3. And so you got a number, 8 times the number between 2 and 3 divided by 7. And this looks like, that would be like, this is saying it's below -3, it looks like, or above. I can't quite tell. No, excuse me. It's below -2 and above -3 approximately, which is consistent with this if you check out the approximation for this, okay? And again, in a similar way, this point up here this would also be 4 1/7 up here, but then it would be minus this, okay? So anyway, we got it. I think it's kind of neat. Both of those points are 4 away from the points, the respective points on the circle of radius 5. So I guess, let's see. These are the answers. Well, actually, sorry. The actual answers you'd have to write them in complex form. So in other words, let's do that real quickly. Your answers would be 4 1/7 plus or minus, we'll write that in the lazy man's format, 8 square root of 6 over 7i, over 7 times I, right? So we've written it in the so-called standard form a plus bi. 4 1/7 being a, and then plus or minus 8 root 6 over 7 being b, the imaginary part. Hope you enjoyed.